with this. Yeah, so that was the initial idea for me.
Yeah.
And basically, I chose this because, yeah, it's a rover and a wheeled robot. So that's the only reason I chose it.
Sorry, Anuraj, I forgot to start recording in time. So can you do like the first part, 30-second summary again for people's
Yeah.
microcontroller part? Yeah.
Yeah, so basically a modular robot for me, how I would build is I would connect like everything with a small microcontroller on it, and then basically a robot becomes a swarm of microcontrollers. And the example would be like if you want to build a wheeled robot, then you connect each wheel with a microcontroller, and then you connect different a number of wheels together, build different types of rovers, and then chassis mechanical. I don't know enough how to make it modular, but that was the idea. So there is something I found last week. There is a framework called Luos, Luos, and they are basically like trying to build software or like the framework or the messaging protocol that advertises the uh, so it's like their idea is to have like microservices for robotics. So each microcontroller advertises the kind of services provide. So if the motor, if it has a motor, then it would basically advertise the service of the angle and the torque as on the network, and then the other parts of the robot can know it. So that is something we could explore. And yeah, this was the example. I posted this in the Discord channel before too about this. This is a concept rover. Somebody has built it, but it's just an animation. Yeah, so that was the idea.
Okay. Venkatesh, do you want to go now?
Sure. Yeah, I'm looking at this picture of Anuraj. It really looks very punk. I like it. All right. Yeah. So I think,
What Anurag shows is two wheels with no tail.
It's actually 6 wheels.
yeah,
Oh, I was looking at the part above.
So if you play the video, you will know.
Why don't we do that? Yeah.
Surface of the moon. Today, there is renewed passion to explore for our next human endeavor. Mars, the red planet, further than any human has ever been. We face many challenges: remoteness, no livable atmosphere, high radiation, dust storms, and extremely low temperatures. Before any humans set foot on Mars, we must first design a protective shelter. We will protect our astronauts from radiation with a thick 3D printed shell structure using Martian regolith, which works great in compression but does not perform well under tension. To overcome this shortfall, we have chosen to construct the pressure retaining parts of the habitat from lightweight inflatable pods. They will be made out of high precision engineered composites that are prefabricated on Earth. Their elliptoid geometry will be able to mitigate the pressure differences whilst optimizing spatial planning. To create the base on Mars, we will use a two-phase approach. In phase one, an ecosystem of 3D printing robots will arrive months in advance of any human explorer. They will construct the protective shield for the base by adopting a modular robotic swarm strategy, a plan that allows for redundancies and enhances the odds for success. Intelligent autonomous robots will have interchangeable roles, from battery storage to scout rovers, logistics to excavational, and even 3D printing units, all integrated with multiple cameras and sensors for navigation. They can reconfigure themselves for a multitude of purposes, ensuring prolonged usage beyond the initial build phases. The smallest configuration is the one-wheeled scout rover that uses ultrasonic scanning to analyze the Martian surface to determine the best regions for obtaining optimum regolith. The digger receives the location coordinates and then excavates the Martian soil. It then delivers the payload to the refining assemblies. Here, large chunks of Martian regolith can be processed down to a finer grain and then delivered to the melter robots in situ. They then use concentrated microwaves to melt the regolith and extrude through the 3D printing muscle. The shell is autonomously 3D printed, layer by layer, over several months by the robotic system. In the next phase, the first astronauts arrive with the habitation units, equipment, and supplies. The robots now take on their second life roles to aid the next phase. They come together to make flexible mobile platforms that can carry the payload from the loading zone to the base. A convoy begins its journey across the Martian surface to the habitat site. The build commences with a connector module placed underneath the protective shield and ready for inflation. The module then unfolds and self-inflates into its final form. The habitation units are then placed into position and sequentially inflated to form the completed pressurized environments. The circular layout of the habitat ensures continuous accessibility of the habitat in the event of catastrophic failure. Each connector module houses 3 integrated environmental control life support systems, delivering essential services like power, water, data, and oxygen to all the habitation units. A circular conduit delivers these services to multiple endpoints in each pod. The base will be remotely powered by 2 nuclear kilopower reactors and a solar farm, located a safe distance away from the base. In the next stage, the astronauts will construct and install a flat-pack, rail-based racking system capable of connecting to the distribution system, enabling spaces to reconfigure according to their spatial needs. This modular and radical design principle has been adopted for all habitat pods, ensuring multi-use, reconfigurable environments. A Martian base should not just be a habitat. It is home for the astronauts. Each pod expresses its own identity, quality, and character. A highly functional design which places the human experience at the core. Spaces include a state-of-the-art research laboratory, a hydroponic greenhouse.
Yeah, it's about the rover part is mostly done.
Can you go back to the part where they show us the rovers connecting and disconnecting to each other?
The success of human, they come together to make flexible mobile platforms. This is the Martian soil.
A bit before that.
Refining assemblies. Here, large chunks of Martian regolith can be processed down to a finer grain and then delivered to the melter robots in situ. They then use concentrated microwaves to melt the regolith.
Okay, can you stop here for a second? Can you stop it? Yeah, okay, so here's my question. I mean, they have a very radically different design for modular, where most of the modular is what we call the large components. And my question is, are we interested in making something like this, except instead of having one big fat wheel, we would probably have 3 wheels, because then we don't have to deal with a balance problem.
That's basically one of my ideas. So my first idea, which is the bogie-based system, is basically a 2-wheel version of this. I think 2 wheels that look like a motorcycle can be a very low-end way of doing something like this. This is much more radical than I thought, but yeah, I'm thinking along the same directions.
But the 2 wheels, okay, fine. So maybe you should present. I'm just thinking out loud. The 2 wheels is not as symmetrical as having a single wheel.
Yeah, definitely. But a single wheel does mean you want gyroscopic balance on each, which is
Also, 2 wheels, you know, you can flip, you can fall sideways.
so if you make the wheelbase broad enough, you won't. So that's, in fact, this was the very first 3D printed thing that I made. If you remember, I made a small black design study. I made the wheel really wide for exactly this reason. I wanted, 3-wheel bogies that could just stand alone like a 3-wheel motorcycle. But yeah, where were we? I want to finish watching this though. It was interesting.
Equipped workshop with visual application facilities. The sleeping quarters with gym facilities and immersive virtual reality platform. We believe that the key to success of human habitation on Mars is the health and well-being of its residents. Creating a place where work, life, and living combine holistically to ensure they feel connected to each other, to themselves, and somehow to their distant home.
The one like problem they didn't think of is the they are assuming it to be an even surface. So that's why those kind of robots will work easily on that surface. But if it's not, then like there has to be some modularity in the chassis too.
I think they're assuming that for a base, you would pick out like a flat plane type of landing zone. But if you wanted to do an explorer mission, then yeah, you'd need like a more terrain capable rover.
But they also have the robots climbing all over the habitat. And then they use individual robots. In other words, when the surface is not uniform, you have a single gyroscopically stabilized wheel. And when the surface is uniform, you can have 5x5 carrying a box.
I think single wheel properly designed will have some good terrain capabilities, but not as much as like a proper articulated rocker bogie, because the way the rocker bogie system works is the different wheels have like traction compensation. So one wheel is slipping, the other wheel will sort of provide the traction. So a single wheel, I think, will fundamentally not have as much terrain capability as multi-wheel systems because of slippage. But yeah, I could talk about.
Do you remember the ball robot? It's just a ball with
Yeah.
two little things sticking on the side. So,
I actually bought one several years ago. A Kickstarter had it. It was like a tennis ball sized one. It wasn't very good. It's a popular idea that researchers love to do, the sphere ball shaped robots, but it doesn't seem to work very well. But its big advantage is if it falls down a slope and rolls down, it can usually self-right and like recover. It has good recovery, but it doesn't have like good traction, I think. Good traction, I think cylinders are a better form factor than spheres. But yeah, my first idea is basically what you just saw, except two-wheel units instead of one-wheel units. And I was thinking of basically two types of medium-sized atoms. One would be wheel units like we saw, but the other would be chassis units, things without wheels, basically. So the basic version would be just like a truck, open box, open top box. So two bogies would come from either side and grasp it, and suddenly you have a truck. Or the middle platform can be like, it can manipulator a base platform, or it can hold like a comms module, or just a powerful computer, so it becomes a compute module. The basic grammar of the system would be wheeled units running around and picking up chassis units between them. And the chassis units should be able to connect so you can form trains. So you can form arbitrary trains. And if you're not making them mobile, they become like stationary units. So chassis can just sit around being like, a stationary base. So you blur the distinction between a rover and a base station using this design. So that's my first idea. And this one, the wheels don't have to be super high powered. So you can do the traction problem by providing engine like rovers that have much more traction capability and higher powered motors. But while you're on a relatively flat surface, you can use like the wheel modules to do like lightweight stuff. The second idea I had was a kind of hub spoke platform, by which I mean the component graph, not that the thing literally looks like a spider. So by the hub, I mean like a central, fairly integrated and not modular thing with lots of like bays where it can store effectively leaf node components. So if you look at the mechanical design like a graph with, or more like a tree with a lot of leaf nodes, the leaf nodes are the modules and the core is the hub, as I'm calling it. So you can think of it as like the chassis would be like the body with like hub points for wheels, hard points for carrying like external tanks and things like that. And maybe a manipulator without an end effector. But the key idea would be you'd have like room for a library of parts. So like, many machine tools have this, many, repair people often have like a pickup truck with like, slots for tools. That's the basic configuration I'm thinking of, where you have like a basic platform and then you have like a bandwidth of like, say, 10 to 15 slots where you can put different components depending on the mission. So if you're going on like a mining mission, you would put a lot of like, drilling and crushing end effectors in there, and maybe you'd put like heavy duty wheels on your hubs. But if you're doing some other kind of mission, maybe it would be science instruments in the bay and lighter weight wheels. So that's the basic idea. And the hard points could use like, that's the aircraft system. So aircraft often have like hard points where depending on the mission, you can have like more extra fuel tanks for long range missions, weapons base for like missiles, or, telecom base if it's like a surveillance missions. So I'm borrowing that idea from the hard point idea of airplanes. Should make a note of that here. And the third idea is, just start with the YakRover design that Yasha's making up, and ask how do you modularize it. So I didn't come up with anything very creative, but it seems like the basic breakdown of that structure is the wheel units would be like independently powered with a microcontroller like Anuraj had, and the middle plus tail would be another component, and the payload would probably be on a third kind of component. So it would be again a mid-sized modularity vocabulary with wheels, chassis, and payload deck. So yeah, those are my three ideas.
Okay, so Yvette, you're going to be a very good segue to the next step. So I'm not skipping you. Here's the three options I thought of. Option number one, we take some sort of existing construction toy, maybe the ones that showed us, maybe Meccano, and we provide an add-on which provides data and power between the attached components. So not every component needs to have data and power capability. Maybe we also choose a toys that you can print out the parts 3D. What I'd really like is if the data is all using Bluetooth links. So we have a mesh of Bluetooth elements, and then the only, let's call it wiring we need is power wiring, which has fewer problems, I think, than data wiring. The internal organs, you know, power, storage, CPU, and so on, will all be in one block, and you can simply get a bigger block if you need one. This means that the motorized parts need to be smarter. You can't have stupid parts because we don't really have any bus dedicated from a motor controller to the robotic wheel. And the connections are manually robust. And what that means is you can't have the robot picking up a piece and becoming bigger. So that's option number one. In option number two, we define a set of building blocks and a set of terminals, you know, like motors, sensors, and so on. Hopefully, except for some electronic sections, everything is 3D printable. The blocks will have a conduit for cables, and we're going to use standard cables and connectors, maybe the CAN bus or something like that. The motorized parts don't need to be smart because they're sitting on that. And again, the connections are all strong connections. In option number three, I thought that we will only think about add-ons. In other words, we're not providing the robot. You can buy any robot you want. But if your robot has a certain center of gravity and has a flat area, you can add on our components. And then we need to have two types of connectors, one to connect to existing robots and one to connect between the units. Now, in all of these cases, I believe in having not a tiny brain, but a robust one that can run ROS. I think the configuration, to the extent possible, should be self-configuration. Basically, what Anwar said, each one has a microprocessor, but at least each one tells the central brain, here I am, here's what I am. And the base station can be exactly the same as a bot, but it doesn't need motors and probably will have more power storage. So these are the modular kits that I envision. And as to the answer to why, option one, I like it because it has the advantage that we don't have to think past. I mean, I showed the example of that kit that's coming out for the robots from Lego. And Venkatesh said, oh yeah, maybe I can add on a power wheel. So the fact that we have all of the Lego connectors and the Techno connectors and we don't have to redo it, I really like that in option one. Option two has the advantage that we have more control over the components, so we can perhaps have fewer components. People can add on new components if they want. Instead of Lego, which has to be snap fit, you know, it has to be very, very precise, we can be more flexible. And the question going through my mind all the time is, how does a hobbyist build his first robot? And then after the hobbyist finishes their first robot, how easy it for them to start tweaking the design and make small incremental changes until they get somewhere else. Okay, so that was my options. Now, Rhett, correct me if I'm wrong, looked at it more as questions that we need to think about. And the next step in what we were going to do was that we do a group mashup in order to choose one proposal. And I think it would be very helpful if before we do that, Vet explains his questions. And based on that, we try to take all of these suggestions that we had here and make one suggestion which also answers Vet's questions.
Yeah, I can go through these. Some of it could be a function of having missed a couple of maybe the important discussions around this subject. But I think ultimately, I'm just like, I don't know who this is for, who needs a kit, and like, how do you design a kit to meet that need? The second thing is, I don't know if any of us have built enough hardware to know what the right trade-offs are for things. Like, if you were going to, and I'm coming at this, and this goes to the next point here. I'm coming at this from a kind of a software perspective of like, you can't build a framework as your very first thing because you don't know what the important parts are. And you have to, maybe you have to prototype something, maybe you have to get some experience under your belt of building 3 or 4 of these things. And then you can start to see what the generalizations are that are important. But there's also this aspect of like hearing some of the proposals. I'm like, well, maybe I don't even know what modular robot is. What would a not modular robot be? And does that even a question that makes sense?
Let me just answer your question. We had 3 meetings of Joshua and 3 meetings of me, and like that.
Mm-hmm.
What Joshua was doing is he was showing his YARG, which is a basic, simple robot that anybody can build. I don't know, we don't have a price point, but let's say for $50, most of it's 3D printed, standard components. There's a piece missing here, maybe the PCB, but that's the YARG, and that's one direction.
Mm-hmm.
And the other direction was we're going to build the kit, and kits are things that people can play with, and that way people play with it. And I did these brainstormings about what do we mean when we say modular and when we say kits. And Joshua did sessions where he showed that his YARG is doable and reasonable, and most important, once you have it, you can start playing with it and do all sorts of interesting stuff. So in both cases, there's 2 customers. One is the people on this call who are going to have to do the work in order to turn it into a spec that's buildable, and who is the users of the robot. I believe it's robot hobbyists that want to do some hands-on, but not too much. But I'm open to hearing, alternative views. That's just how I see it.
I think I had been interpreting the other track of Mojave Desert Robot as less about an external customer. Like, it's less important to be able to build something that's to provide instructions for other people to build robots than it was for us to build a robot. Maybe we all build the same one, but it's about a specific mission. And like, success is, does a robot drive in the Mojave Desert? Not, success is not, does 10 other people build the same robot also and enjoy doing so? Whereas I think for the kit, it seems more clear that success is about having an ecosystem that other people can participate with and find it entertaining. Probably because a lot of the things that we see off the shelf today don't quite meet our definitions of what makes a good kit. Does that sound correct?
I would just say that at the end of the year, if we go through the YARG pathway, absolutely other people will copy what we're doing. Okay. And if we build a kit and we finish it at the end of the year, other people will be copying what we're doing. So the proof of having a kit is that we say it's wonderful, but the proof of a working YARG is the YARG works, and therefore people should copy it. Okay, I mean, I'm looking at next year, not at this year. This year we're going to be building hardware, software, mechanical, electrical of a robot. Is it going to be a single robot, which is a much more focused task, which helps with all sorts of stuff and clear endpoints and clear measurements and so on? Or is it going to be something more general like a kit where it's more difficult to know that you succeeded and so on? But a year from now, I think we're in exactly the same place. But again, that's just my personal opinions, not.
Looks like Venkatesh is talking, but muted.
Oh, sorry, I was muted. Yeah, my sense of the overlap is that the PCB discussion we've been having is actually the driving design constraint and sort of not bottleneck, but the thing that if we decide it'll determine the fates of both the YARG direction and the modular direction. So for example, if we have like one small lizard brain per wheel, so a 2x redundant YARG with two little lizard brains, one per wheel, and one slightly heavier brain in the chassis, that automatically lends itself to several of the ideas we were talking about today. Because in the future, you can say, all right, replace that little lizard brain with a slightly more powerful thing and make that wheel autonomous, and it becomes a sidecar bogie system, or like replace the coupling with a snap-on coupling and it changes, right? So in a way, I think even though it's more obvious to focus on the physical design, and the hardest part is probably going to be the operating system and code levels above the electronics, I think the system design driver is how you choose to do the electronics board and what processors you put where and how you connect them. So if you put them all in a single PCB with like a slot for putting in a larger processor, that takes you down one set of directions. If on the other hand, you have like a few breakout boards with like, multiple small and big processors, it opens up a whole different part of design space. So my thought is actually the first attempt at convergence in the next few weeks, when we talk about both projects together, we should talk about basically the PCB plus choice of processors. Seems like it drives everything else. Also, like indirectly, that drives how much power you'll draw. The power draws sort of determines the battery and where it'll be carried. So it sort of like drives everything else once you pick what processors you're going to put and where.
Yeah, I was going to say power is it drives everything about the design, which is like, I guess what Josh has been kind of trying to beat into our heads, realizing that like, oh, you've suddenly got a whole lot of constraints if you're trying to be solar powered.
Exactly. If you have a mission and the mission describes where you get your power from, then it really defines what your first robot will look like. I'm sure once we build the YARG, you can replace a solar panel with a set of batteries. Okay. I mean, that's not a problem. That's what Venkatesh is saying. If we make the connectors, let's call it modular, we can start replacing parts.
Yeah, that's why I said the processors rather than the power is the main constraint, because depending on how you set up the processors and the electronics layer, then options like, can you control a more powerful motor become like, design variables. And then you can be like, can I add another battery and like put 2 more amps into the power bus versus like keep it a low power robot. But I think the set of processors, once you pick that, it actually constrains a lot of other things, including, motors and things and power.
Well, processor, like the driving thing the main thing that would be like uh, choosing the energy, or using the energy would be the motors. So basically, we had to have a power budget, and then like what motors we'll choose, and then because the microcontrollers and other stuff wouldn't take, like they wouldn't be mattering in the overall energy budget, so they would be so less. Except maybe if we use a Linux computer, so maybe we consider that, but the otherwise, like the other things won't matter much. So the main energy consumption would be coming from the motors and how long we run them. So that would decide our power budget.
But that's the difference between doing a Yakusar, which has a power budget, and doing a kit, which doesn't have a power budget because it doesn't have a mission. Okay, this kit is not meant to sit in the Mojave for 24 hours and do something.
But sounds like the power budget, the modularity idea that you proposed can actually be incorporated into something like the Yakusar. Like you could have a bay that can hold either like a, I don't know, 2000 milliamp hour battery or 1000 milliamp hour battery, and support either a 2 amp or a 5 amp draw. So it feels like a modular decision to me. The only thing you'd really need is to make sure the power lines can carry that much current.
Yeah, so that I think touches again on to this "you aren't going to need it" principle that I referenced, that comes up in software a lot. Of like, we're talking about the architecture. You could spend a whole lot of time making sure that each piece is completely replaceable and can support all missions. But there's the risk of like you spent a whole lot of time on that, and then you never actually needed it because you never had a mission that needed that size of battery or whatever. But like you had to spend a whole lot of time up front coming up with these requirements, these potential requirements, and making sure the kit meets all of them. And then you actually only needed 10% of them, but you're not sure which 10% was. And so I think the Yakusar kind of focused approach of just like choosing the one mission, set the requirements just for that one mission, and you learn a lot about what those are going to be, how they're going to work out. It's
Absolutely.
more reasonable to me, I guess. Or yeah, I don't know. Kits sound really hard. Maybe that's what I'm saying.
Yeah, but today we're talking about the kit.
Great.
Next week
Yeah.
we'll talk about. Okay, so I'm starting to write what's the proposed structure. I mean, these things seem to be in agreement that we want to use smart components with similar processors. Right?
I think we all
And
agree that's a very interesting architectural
yeah,
direction
and
to have
we
smart
want
components.
we want the data bus to allow them to work together, not just, independent. The base station will definitely be able to have modular power storage.
The data bus, by that you also include the control bus, so something like I2C or CAN, or is that what you're talking about there? Okay, so you are, yeah.
You mean the physical layer of the communication channel, right?
No. I'm saying that maybe we have two data buses. One is for the microprocessors to talk to each other, so they can really act as a swarm, and the other one is for the sensor to send data to the microprocessor.
So
You
this,
don't want to use I2C as a data conduit between two microprocessors.
But why can't be everything just one protocol? It's like, so I2C is a multi-master protocol, so it doesn't matter. So everything can be on the same bus. It's the same with CAN. CAN is a little more complicated.
And everything has a processor, right?
Yeah,
Yeah.
so I2C and I2C like I can have multiple masters on the same two wires. It's the same with CAN.
But they all have to use the I2C protocol. I'm saying that the I2C protocol, I think, is not so good for processors to work together. That's what I'm
Um, well, why? You could have like Ethernet, but then that becomes really complicated. So CAN is a little
Ethernet is
simpler than that.
also Ethernet is also not so good for processors to work together.
What do you mean processes working together exactly? Like I'm just thinking of like an RPi telling a motor to turn on and off, or a
So
sensor.
that you can do an I2C.
Okay, so
But
what do you?
if you want little lizard brains to get together and become a big bad dinosaur brain, they need a little bit more coupling, I think, than the I2C can give them.
So that's what multi-master will do that.
Well,
Multi-master
it
just
so
sorry.
just depends on the bandwidth. So I2C is like the normal mode is depend I think around is 400 kilohertz. So if you have like large amounts of data to be exchanged between the processors that would be connected on the channel, then maybe I2C is not the way.
I guess the
Prob-
most demanding data would be a video stream. So I assume all designs will have a video camera. So that's going to be driving everything then.
Yeah.
No, then I2C is not the way.
Okay. So we should assume video because that feels like a deal breaker to not have video.
So
Well-
that's probably why so many of these high-end robots use Ethernet for everything.
Probably because like even CAN is I think around 1 Mbps.
Yeah, but
So
I
it's
can
like-
send data like video by Bluetooth. I don't need the data to go from everywhere to everywhere all the time. Think.
So video could be a special case link. So you have a generic data bus for everything else, and then video is a special bus that goes only from camera to maybe the big computer. So we can think of video just conceptually as a separate
Oh,
thing.
but there is no big computer, not necessarily.
Oh, okay.
but it can be Wi-Fi, right? Uh,
Or you're gonna have a Wi-Fi component or some other.
so ESP32
Modem.
has both Bluetooth and Wi-Fi, so you can use either one.
Isn't Bluetooth better for short range, high throughput?
The
Lower
data
power.
throughputs, yeah, I don't know about both of them, but
Well, so I was thinking in a modular platform though, one of your modules is gonna be like an antenna, and like it's the component that you can actually communicate with the rover over. And it's gonna need to be part of the same bus, but it will be separate.
Yeah, but we're talking now about the boxes fitting together. You're talking about the rover being more capable.
But one of the boxes has to be the communication module, right? And so if that
If we
box is
want
what's gonna
that.
be sending the video, then it's gotta be on whatever this video bus
well
is.
the well the physical layer we can choose anything. So there is something called the CubeSat protocol. I think I've posted it a few days ago. So that is actually supported by one of the space companies here in Europe.
Okay, can we talk though about other items? I mean, what kind of components? Are we going towards a atomic component like here in the picture, a wheel with a box? Two wheels with a box, like Venkatesh says?
So I think it'll be easiest to decide the scale people are looking at. So for me, medium-sized atoms of approximately a wheel size seems to make the most sense. Or do people want to go bigger or larger? You can have entire robots be the modules or somewhat smaller.
Okay,
The way I would think of it is single function large atoms. So a wheel is a single function in the sense that it just rotates and moves something along. A camera is a single function unit. A manipulator is a single function unit. So I would basically say it does one thing. So
yeah, well, I'm not sure what that means. These wheels If you put two of them together, one of them can hold you in place and the other one can dig in the ground.
Yes, so that would be a higher level sort of like behavior you program in somehow, either at a big central computer or through a swarm behavior between two small computers. But the basic physical behavior that's observable is that it controls the turning of a wheel, right? It doesn't control, think of it
Yeah.
in terms of like fundamental output signals it can manage.
All the atoms gonna have the same dimensions? It's
Not
ugly.
necessarily, but they will have one function, as in all the dimensions will contribute towards fulfilling one function.
No, I understand, but are they gonna be an inch by an inch by an inch? You're gonna have two sizes, 1 by 1 by 1, 2 by 2 by 2, or how do you want to do it?
I don't think that needs to be designed at the modularity level, like physical dimensions don't need.
No, how many physical dimensions will you have?
Oh,
If you buy an IKEA kitchen, every cabinet is either 30 centimeters, it's a multiple of 30 centimeters. Okay? So when you say atoms have a single function, got that, do they also have a unit size? You can
Oh.
have a 2U a box.
yeah, got it. Got it. So like a form factor modularity, basically.
Yeah.
Physically, my intuition is it's possible. Like I can imagine wheels and cameras and particular kinds of actuators all fitting into like similar, like, 1U type boxes. But yeah, I would say, yeah, you would have form factor modularity is doable.
Okay. And how do people here envision the different modules being connected together, the physical connection? Going to be with screws, going to be snap connected, going to be magic, actuated connection. I mean, again, this
Screws.
castle is, magic connection.
I would definitely say screws, because the snap connections tend to be either you need too much precision or they'll fall apart easily. And anything like a smart connection, I think, is out of scope for a 1-year design spec. So yeah, there'd just be a pattern of holes and you'd connect them. So it's not going to be automated. If you want to do snap fit, I think Lego is the only option, since we wouldn't be engineering our own like precision snap fit
Yeah.
language.
Constructs, I thought, worked better than Legos.
Oh, that's
For
the
that.
one you're using, right?
Yeah,
That's
and can be
manufactured?
physical, and can be 3D printed fairly reasonably.
Oh, okay.
Yeah. It's definitely inspiring me when I talk about using a standard toy. When I used the vector set, we would always be losing the little nuts.
That's definitely the case.
Use a short bolt, and then the nut can just fall off. And if you use a long bolt, it gets stuck when pieces move.
Yeah, I think the only reason I'm partial to fasteners is we are talking about rovers, not sort of super domestic safe environment ones. These things are going to fall and topple over, and yeah, snap fits fall.
Okay, does this proposal make sense? Are we missing some critical feature?
I think you should have at least the initial opinion on the electronics, physical stuff. Is it going to be a single PCB at the heart of the thing, or multiple little
There's
breakout?
no heart. Oh, wait, I understand you. So no heart.
Okay. So then this fits within the form factor modularity. Like each of these form factor boxes
Yep.
will contain an electronic component and then have electrical connections. Okay.
Would it make sense to list out some of the modules? More than you have atoms of a single function, wheel, camera, etc. But
So we have one special module. The chassis is going to be like, well, the chassis can still be a multiple of the unit size. So yeah, chassis, wheels, camera, and at least one kind of like gripper type actuator, I think is the minimum viable language here.
And comms. Got to communicate with us now.
Yeah.
And we also need power.
Yes, power. It's about to say. Power source is the one thing that might violate sort of form factor modularity, because if you go with solar, the incident radiation will determine the shape and size, not yeah. But that's fine. This is, I think of modularity as like good defaults rather than like, you know, enforced uniformity. So sometimes you will need to break some patterns.
Yeah, well, even for solar, so like in my rover that was constructs based, it's definitely like limited. There's limited dimensions that you can use for things, and it broke down for my battery pack that was just a little bit too large for the big square that you'd make. It just doesn't quite work, and there's just not really a good way to. You can't, if you do one larger, it's just way too big.
But next time, you know,
yeah.
just chop down the edge of the battery.
Yeah, exactly. I'm like, how thick is this protective cover? But it does, like, if you had, I didn't like choose the dimensions, right? It's just what they were. But when you have something like you have squares and you can make them by 4 wide, like that gets pretty flexible pretty fast. Even for something like a solar panel, if you can fit within some multiple dimensions, I think that works.
Well, it possibly the solar panel is a component that you attach on.
Yeah.
It's a modular component, 1U, you can put 10 of them.
One thing you can add as like a weird option is if you have flexible or you know, compliant components, some of these things are capable of being stretched or bent or warped over each other. So not everything has to be a rigid body, like including electronics, right? There's like ways to do electronics with slightly flexible boards and things that can be like twisted into shape or squeezed into corners. I haven't looked into anything other than mechanical, but mechanical, definitely you can do things like this. Like that's one of the reasons I like Meccano, because many of the strips are like flexible. You can bend them over each other.
That's only a little bit flexible.
Yeah, slight flexible, but you can go all the way to like things made of foam.
Yeah.
Do the Meccano, like off-the-shelf designs, have you bend pieces?
Have I what?
Do the Meccano like designs that you build from the documentation, do those ever have you bend?
Yeah.
Yeah, absolutely.
Oh, okay.
Absolutely. You have, for example, cranes. They start parallel and then meet at a tip.
Yep. They have you bend them, and they also have like the later kits have not just metal but like specific flexible plastic and rubber components that are designed to be squeezed and stuff. So it just has a larger material range than something like Lego.
Yeah.
But we are 6 minutes over, so we should probably wrap up.
I'll just ask if what we have here is something that we can handle. There's not much PCB design, because each component itself is going to be simple. And instead of having a PCB, we have a bus, which is all over the place. So we're going to have to do more processing to handle it. And Anurag suggested we're going to have smart terminators to prevent reflections and I don't know what. But is this something we can do?
I have a question here. So logically, the rover, as it thinks of itself from the inside, it's really not a single device. It's a bunch of little Arduino-sized dumb computers that know about a communication module that they can talk to get the data in and out. But other than that, they don't have any default awareness of anything else they're connected to, right? So the video controller does not know that it's actually sitting on a vehicle with a couple of motor controller boards and things like that. So it's kind of like a cloud that's vaguely self-aware moving around.
Yeah, but you still need kind of a central, either a module or controller to like orchestrate all of them.
Okay, so we do have some orchestration. It's not okay.
Yeah, so you will need something. So it can be like the same kind of module. So we choose the same powerful one for each module, or we have like a RPi or our own computer, which we control over the network.
I think you just described a heart.
That's
No,
what.
no, 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 no.
Or well, heart I would call the power, and brain I would say.
Oh, we should probably think of a brain also as another standard module. Like it's not playing a critical linchpin role, but it can be a little box that you tack on, like
A
just to-
GPU.
Yeah, but it's not an essential component. That's why
Yeah,
it's not listed here.
exactly.
You know, the Apple II used a 6502 processor as a CPU, but the disk drive also used a 6502 processor when they had a disk drive. So that's how I'm looking at it. You know, the fact that you have a processor doing one thing and a different processor doing something else, together it's a cloud. So it was decided that the CPU on the motherboard sends commands to the CPU in the disk drive. But only decided, and the CPUs themselves are exactly the same CPU. So that's why I'm saying I don't have a heart, I don't have a big brain.
Hmm.
You know what? I can do it maybe in software, but if not, I'll have a box and say, this box, I'm using its Arduino to give instructions to other boxes. But it's
Yeah, but
not.
if you want, like you cannot do anything more computationally heavy on a small brain.
Absolutely correct.
I gotta drop off, guys.
Yep.
Yeah.
Catch y'all later.
All right.
Yeah.
Yeah, I think this is basically an interesting design spec. It would be nice to have like a bunch of little Arduino ESP sized things connected in, I guess, almost like a VPN, but like a very low level analog to a VPN. Like they'll be aware of each other's addresses and maybe exchange a little data, but fundamentally orchestrated to a comms unit.
But there's definitely some interesting software architecture to do here. There'll be a list, they'll register, they'll be able to ask for help. I don't know.
So there's something called Luos. You could check it out. It's like a embedded
Yeah.
systems orchestrator.
Yeah, you
Put
would.
link.
Right. Let me stop here.